Pavitra V, Department of Chemistry. Today we are going to discuss a topic called fuel. First we will discuss its definition. What is fuel? Fuel is actually a combustible substance which contains carbon as a main constituent in it and which on burning will release enormous amount of heat energy. So this heat energy can be used economically for domestic and industrial purpose. When we come to the classification of fuels with examples, first is the primary fuels. They are naturally occurring fuels that can be used directly or with minimal process. For example, coal, wood, petroleum and natural gases. The second one is secondary fuels. These are derived from the primary fuels. So for example, gasoline, that is refined petroleum gas, diesel, liquefied petroleum gas, that is LPG, coal tar, etc. Next is fossil fuels. So these are formed from ancient plants and animals over millions of years inside the earth crust. So for example, coal, petroleum, natural gas, etc. Next one is renewable fuels. So these are derived from sustainable sources and can be replenished naturally. For example, biofuels, which will evolve ethanol from plants. Next is biogas from organic waste or cow dung, hydrogen fuels, etc. Next is nuclear fuels. These are obtained from nuclear reactors in which we will use nuclear fuels to release enormous amount of energy due to nuclear reactions. Example, uranium, plutonium, etc. Next classification includes solid fuels, liquid fuels and gaseous fuels based on their physical state. If it is solid, then it is called solid fuels. Example, coal, wood, charcoal. If the physical state is liquid, then they are called liquid fuels. Example, gasoline, diesel, fuel oils, etc. So if it is gaseous in nature, then it is called gaseous fuels. Example, natural gas, liquefied petroleum gas, that is LPG. Next we will discuss what are the characteristics of a good fuel. So it should be having a high calorific value, that is when 1 gram of fuel burned completely, the amount of energy evolved is given by calorific value, 1 gram of the fuel. So the calorific value should be high for the good fuel, low moisture content so that it will increase the calorific value and the efficiency of the fuel. Next is moderate ignition temperature. The fuel should have a moderate ignition temperature so that it can be ignite and burn efficiently, easy to handle and store. So this is also a very important character for a good fuel. So it can be easily stored, transport and handled without any significant risk of leakage or degradations. Next point is safe to use. The fuel should be inflammable, less toxic in nature, reduce the risk of accidents, and it should not be harm for any human beings, animals and to the environment. It should be less. The next point is clean burning. The fuel should undergo complete burning, low emission. The emission of carbon dioxide, carbon monoxide, sulfur dioxide, that should be less after burning. Next is cost effective. It should be moderately cheap and it should be economically variable for various applications. Next is abundant and accessible. A good fuel source should be readily available and accessible to meet the demand. So next is the definition of calorific value that I have already discussed. Calorific value is also known as heating value, that is the amount of energy released when 1 unit of fuel or 1 gram of fuel is completely burned. Then there is that measurement will give you the calorific value. The unit of calorific value is mass or volume, that is energy per unit of mass or volume, such as megajoules per kilogram. This is the unit of calorific value. Next is the instrumentation for the determination of calorific value of a solid or a liquid fuel. So it is also called bomb calorimetric method. So the instrument used is called bomb calorimeter. So the principle is Here in the calorimeter we measures the heat of combustion of a fuel by ignition of a small sample in a sealed chamber, that is we are calling it as a chamber, that is bomb surrounded by water. Due to the combustion there is the increase in the temperature of water, that is measured using the instrument. So when we talk about the procedure, so sample preparation, we have to prepare the sample, we have to weigh accurate weight of the sample, and we should prepare for testing. Bomb calorimeter setup is will be as shown in the figure, and it should be filled with oxygen and sealed to get a oxygen for combustion. Next is ignition, temperature measurement. For this we will use the thermometer, and calculation of the calorific value, and this is the formula for calculation of calorific value: temperature rise into water equivalent divided by sample mass. So this is the apparatus setup of bomb calorimeter. It consists of a copper calorimeter in the outside chamber. Inside it is filled with the water. This is the water part, and this sealed compartment is called bomb, which is sealed, and this is the oxygen inlet valve, which is used for combustion, and these two are the electrodes. This is crucible. Inside the crucible we place our fuel. So this is the fuel sample, it is fused. So whenever there is a oxygen enters into the bomb, there is a combustion takes place. So during combustion there is a release of energy. That energy will increase the temperature inside the bomb. That water will absorb the temperature, and the temperature of water will increase, and the increase in temperature is noted using the thermometer. So this is thermometer placed. So the continuous circulation of water is done through the stirrer. So stirrer will stir in order to maintain the uniform temperature throughout the water stored in copper calorimeter. Next topic is comparison between solid, liquid and gaseous fuels. So when we talk about solid, liquid and gaseous fuels, first thing we know that it is differs in physical state. So next is, first point is calorific value. So calorific value is very low when compared to liquid and gaseous fuels. And when we talk about pollution, there is more smoke and burning in solid fuels when compared to liquid fuels and gaseous fuels. So ignition temperature and fire hazards, they possess moderate ignition temperature. The hazards will be very less when compared to liquid fuels, and in gaseous fuels the chances of inflammable and chances of fire hazards is highest. When we talk about the cost of the fuels, solid fuels are little bit cheaper when compared to liquid fuels than compared to gaseous fuels. Next come to the transportation of solid fuels. So it is little bit lesser in cost when compared to liquid fuels. For liquid fuels and gaseous fuels we require a pipelines for transportation. Next is storage. The storage will acquire lot of space for solid fuels, and also less risk when compared to liquid fuels and gaseous fuels. So gaseous fuels we will use some cylinder materials to store it. So next is mode of operation during the combustion. So thermal efficiency is low and ignition temperature is high, so that the combustion will get completed till the oxygen supply is sufficient. So when we compare to liquid and gaseous fuels, always the combustion is complete, and it can be controlled and controlled and adjust the fuel supply.